Hi, my name is Mr. Chona. Welcome you to my study room, especially those who are coming here for the very first time. I hope you have your pen and papers ready so that we can study together. Enjoy your study with me. Thank you. This study is on finding the equation of the tangent to a circle. I have a number of videos on the relationship between the tangent to a circle and the circle itself. And some of these videos I will share the links at the top here, so I'm not going to spend so much time right now talking about the relationship between the equation of a circle and its tangent. The tangent to a circle is a straight line, and again I have a number of videos already on the relationship between a circle and a tangent. Some of the links I'll be sharing with you at the top right now. You can verify them. But then one thing I need to say about this one is that the tangent to a circle is a straight line. For that matter, it has the general equation of a straight line, which is ax plus by plus c equals 0. So this is just what I want to state. We now take the steps in finding the equation of the tangent to a circle. Step 1 says identify the equation of the circle, the center, which we decide to call x1, y1, and a point on the circle, which is t with coordinate x2, y2. Then step 2 says find the gradient of the radius through the point x1, y1 and x2, y2 using the formula m1 equals change in y over change in x. Then step 3 says find the gradient of the tangent as m2 being equal to the negative reciprocal of m1. Then step 4, substitute the coordinate of the point of tangency, that is with coordinate x2, y2, and the gradient of the tangent m2 into the formula y minus y2 equals m2 x minus x2. Then the point 5 says that simplify to obtain the equation of the tangent in the form ax plus by plus c equals 0. Then I put a very important point here, that do not substitute the coordinate of the center into step 4, because the tangent does not pass through the center of the circle. Yes, we want to use a point on the tangent, and the tangent doesn't pass through the center of the circle. It's the point at the circumference of the circle, the t, that is the point in which the tangent passes through. So I just want us to know that. Let's take an example. Our example says that show that the point 3, 2 lie on the circle x squared plus y squared minus 8x plus 2y plus 7 equals 0, and find the equation of the tangent at this point. So we are just going to follow the steps we have stated to find the equation of the tangent. And we'll start by identifying the equation of our circle, our point, and then the center of our circle. This is the equation of our circle and this is our point. And let's go quickly to find the center of the circle by comparing with the general equation of a circle. So by comparing, 2g will be equal to negative 8. Dividing both sides by 2, g will be equal to negative 4. And then 2f will be equal to 2. Dividing both sides by 2, f will be equal to 1. And we know that the center of the circle is negative g negative f, and that will give us 4, negative 1. And this is the center of our circle. So now we have dealt with step 1. We have found the equation of our circle, the point of tangency, and then the center of the circle. And here I just want to state quickly that I did it so fast because the objective of this lesson is not to determine the center of the circle, but rather I have separate videos on how to find the center of a circle, and I'm sharing the link with you at the top here. You can just click on it and check out for yourself how to determine the center of a circle when given the equation. I use different approaches in solving, so you can check that out. So now that we have found that, we are now going to find the gradient of the radius to the circle, and the radius is from the center to the point on the circumference. That will be the radius of the circle. So if this is the center, let me just do that quickly. Instead, let me rearrange the point to the center for negative 1 and the point 3, 2. Alright, so as I always do, I will call this one x1, y1, x2, y2. So we are finding the gradient of the line joining C and T. That is the radius of the circle. And if we decide to call that one M1, then M1 will be changing Y over changing X. And that will give us 2 minus negative 1 over 3 minus 4. That will give us 3 over negative 1. And that will be equal to negative 3. Right, so this is our M1, which is the gradient of the radius to the circle. But now we are looking for M2, which is the gradient of our tangent. And because they are perpendicular, that will be the negative reciprocal of this negative 3. And that will give us 1 over 3. Or those who want to practicalize it, you can multiply negative 3 by M2 and equate it to negative 1. And when you finish, you make M2 the subject. You get the same thing. We are now going to the next step, which is substituting this one, which is the M2, and then this one, which is the point on the circumference where the tangent passes through, into the formula y minus y2 equals M2 x minus x2. So that becomes y minus 2 being equal to 1 over 3 x minus 3. Multiplying through by 3, we are going to have 3 multiplying y minus 2 being equal to x minus 3. Then 3y minus 6 equal to x minus 3. Rearranging and moving all this to the right hand side, you are going to have x minus 3y. This one can become positive 6, so plus 3 equals 0. And this is the equation of the tangent to the circle passing through the point 3, 2. We take another example, and with this example I expect you to pause the video and work it out for yourself. After that, we compare our answers. The second example is find the equation of the tangent to the circle x squared plus y squared minus 6x plus 4y plus 5 equals 0 at the point where it meets the x-axis. So because of the nature of this question, I will demonstrate the circle meeting the x-axis using the GeoGebra app, after which we will come back to the main calculation again. Alright, so here we are in GeoGebra, and we are going to enter the equation of our circle. There you have our circle there. Our tangent can be touching the circle here or here, because these are the places where the circle cuts the x-axis or touches the x-axis. So we'll go back to work it. We have our circle, and then they say where the circle meets the x-axis. So at the point where the circle meets the x-axis, the y value there is 0. We are just going to substitute that into this equation to find the x values there too, and this will give us x squared minus 6x plus 5 equals 0. Solving this, we are going to have so a times c is 5, 2 factors of 5, that when we add we'll get negative 6 is negative 1, negative 5. When we multiply we'll get 5, and when we add we'll get negative 6. And it's either x minus 1 equals 0 or x minus 5 equals 0. So x will be equal to 1 or 5. So that means the circle cuts the x-axis at 1 and 5. And if you want to get a point there, we are going to have 1, 0, and 5, 0. The y coordinate continues to be 0 here and 0 here. Because the circle cut the x-axis twice, he cut it at 1 and he cut it at 5. So I think this will be the right time for us to go back to the GeoGebra app and then verify what I was saying. Alright, so there we have it. Our circle at A cut the x-axis here at A 1, 0, and then B 5, 0. It's even here. The A intersection is 1, 0, and then 5, 0. So this is it. This is how you find the equation of the tangent to this circle at one of the points. They didn't tell us which of them, so I will choose one. Maybe let me choose let me just choose B. Any of them, I can choose one. So I'm choosing B. But then you see that this is the center of the circle. This is the center of the circle. From the equation here we can see the center of the circle is 3, negative 2. So 3, negative 2. This is the center of our circle. Yeah, this is the center of our circle. So now we are connecting this radius of our circle, which is from here to here, from the center here to this line here. Good. So this radius f, we are going to find the gradient of this radius f here. Then we'll use that to find the gradient of a line that is perpendicular to this line. So let me just get that as the tangent. Yes, so this becomes our tangent. G is our tangent, and it's perpendicular because we can measure the angle right now, So I take the angles here to measure to see that this is 90 because it's perpendicular. This is 90 degrees. You can see A is 90 degrees. We'll now get a gradient of this radius here. So I'm going to find the equation of this tangent. Let's go back to our calculation. Alright, so now I am using here, according to the diagram, using the point B. So now that I'm using this point and the center of the circle, I will just rewrite it. I'll write my center here. That with the circle, I don't need to be calculating again. And I'm using the point T50, which is the point B from what we saw on the GeoGebra app. This will be x1, y1, x2, y2. The gradient of the radius will be changing y over changing x, and that will be 0 minus negative 2 over 5 minus 3. So this will give us 2 over 2, which is 1. Rm2, which is the gradient of the tangent, is going to be negative 1. Equation of the tangent is going to be y0 equals negative 1 times x minus 5. Y will be equal to negative x plus 5. If I want to write the general equation of a line, then I'm going to have x plus y minus 5 equals 0. And this is the equation of the tangent to the circle. So you can just use, by going through, you can also use this point. You can find the equation of the tangent at this point just to make you understand, and that equation will be x minus y minus 1 equals 0. That will be the equation of the tangent through the other point A on the GeoGebra. I mean this point through this point. So this is what I'm talking about, the equation of. So let me join here first to get my radius AC. Then I'm now talking about the gradient of this tangent. The equation of this tangent is x minus y minus 1 equal to 0. We can verify all of them from here. The first equation, here is it. I said it's x plus y minus 5 equal to 0. This is just arranging it in another way. So that is perpendicular line BF. This is it. And this one, this is its equation. Negative x plus y equal to negative 1. If I change it back to all of them to one side here, so that, or if I divide through by negative 1, I'm going to get x minus y minus 1 equal to 0. So that is our lesson for the day. So this is where we end today's studies, and I hope it has been of help to you. If yes, why not hit the subscribe button for more videos and also for regular updates on new videos that I make anytime I make a new one. I hope to see you next time in my study room. Until then, it's a bye for now. Bye bye.